Hello everyone. Thanks for joining me today in this session. My name is Vamshi Kondori and I'm a Senior Solutions Architect for Robotics at Amazon Web Services. AWS RoboMaker is the most complete cloud solution for robotic developers to simulate, test, and securely deploy robotic applications at scale. RoboMaker provides a fully managed, scalable infrastructure for simulation that customers use for multi-robot simulation and CI/CD integration with regression testing in simulation. In this demonstration, we will be looking at how to launch a one-click sample application to start a simulation in AWS RoboMaker. We will be using a sample application that the RoboMaker team maintains so that you can quickly get started and look at the functionality that RoboMaker provides. We will be seeing how to use the GUI tools such as GZ Client, RViz, RQT that are native to ROS and Gazebo developers and how to use them on RoboMaker. We will then be using the WorldForge functionality in RoboMaker to generate a simulation world. We will be importing this generating world into your sample application so that you can see the use case of creating the worlds and seamlessly attaching it into your simulation applications. To launch a simulation, we would be needing a ROS package with the URDF description and the corresponding ROS package application that performs the functionality of the robot. We will be using a ROS launch file to invoke the corresponding ROS nodes associated with this application. Similarly, we will also be needing a simulation application built on the Gazebo robot simulator. In this simulation world, we will be virtually creating the robot, the sensors, and describing the world in SDF formats. We will also be having plugins to create the sensor data corresponding to the real physical robot. These applications are compatible with Ubuntu 16.04 and 18.04 versions, and of course you'd be needing an AWS account with the appropriate permissions to launch the simulation in RoboMaker. So let's now look at how you can quickly get started with AWS RoboMaker simulation and see how to launch the simulation job with a single click of a button. In this demo, we are going to show you how you can set up a sample one-click application from AWS RoboMaker and see the functionality that are available in it. Let's begin. So this is my AWS console, and over here, first I search for the RoboMaker service. On the left side of the screen, you can see the functionality that is available in RoboMaker currently. You have a development environment where you can set up a Cloud9 and the robot and simulation applications that have been provided. The WorldForge worlds, which we're going to touch upon later in the demo. Over here is how we generate 3D simulation worlds using AWS RoboMaker WorldForge. And then simulation run gives the information about your simulation jobs and the status of them and how you can access the data from them. Fleet management covers how you've defined robots and how you can deploy code to them. And resources. We are going to use the one-click sample application supported by AWS RoboMaker and access it from here. So let's go ahead and click the sample application sections in the resources tab. Over here, we have two sample applications that are supported by AWS RoboMaker. By support, we mean that when you click this button and click Launch Simulation Jobs, AWS RoboMaker takes care of creating all the resources that are required to build the application, upload it to Amazon S3 bucket, create the robot and simulation apps, and launch the simulation job with the appropriate parameters. When you bring in your applications, you can leverage some of the infrastructure that has already been set up, but you will have to bundle your application and make it available for RoboMaker so that it can pick it up from there. And you can find the source code in this URL. Over here, if you'd like to actually build this application from your local environments or your dev environments, the instructions are available in the README how you can set it up and also how you can set this up on AWS RoboMaker from scratch. This will be a great step to try out after you've seen the tools that are available from the one-click sample application. So let's go back to the one-click sample application and click Launch Simulation Job. When you click Launch Simulation Job, in the background, AWS RoboMaker is kicking off a CloudFormation template. Once again, we search for the CloudFormation service on our console, and you can see that AWS RoboMaker's CloudFormation creation is currently in create and progress state. And if you click the CloudFormation template, you can find the details of what is actually going on in the background. Specifically in the Resources tab, you can see the resources that are being generated in your account by this CloudFormation template. Okay, now we can see that all the resources for our application have been created. So all we have to do now is go back to the RoboMaker console, and under the simulation job section, you can see a new simulation job that is currently being prepared. This simulation will take a couple of minutes to set up while AWS RoboMaker pulls in the robot and simulation application from the Amazon S3 location and sets up a managed environment to run the simulation job in. In the console, you can see different tabs describing the parameters of and configuration of the simulation job. Under configuration, you can see the networking that has been set up, the subnets that have been associated, the security groups, and the compute that we are using for this simulation. Under the robot application, you can see the details of the robot application that was used and the package name and the launch file that was invoked to start the robot application. This launch file will be relevant when we are figuring out how to associate the WorldForge world to your simulation application. We can also provide environment variables to our application so that which you can leverage to change parameters and scenarios within the simulation. Similarly, simulation application has a corresponding package name and a launch file that is used to launch the simulation app. We can also tag our simulation with specific details in case you want to filter it or grab the information later by using AWS API to call specific tags. AWS RoboMaker also writes all the logs that are coming in from your simulation job to Cloudwatch Logs, which you can access from the console page here. Now we see our simulation job has started up, but as I was mentioning just before, under configuration section, you can click the Logs tab to access the Cloudwatch logs that are corresponding to our simulation job. Here are the logs. Here we can check out the logs of our simulation job by just clicking the corresponding log associated with it. When the simulation has completed being set up and is currently running, you can see the tools that are available on the RoboMaker console. This opens up a managed GZ client which will enable you to see the simulation world. Here we can see the bookstore environment that AWS RoboMaker has also open sourced on GitHub, and we can see once we move the world a little bit that the Turtlebot robot is patrolling in this environment. You can also open up RViz and RQT consoles to interact and view the data from your robot. Here you can add the data that you'd like to see from your robot in your RViz configuration by selecting the topics that are of interest. Here, I quickly selected a few ROS topics that I'm interested in to get a sense of what the robot is doing in my simulation world. We can see that it's patrolling autonomously in the environment here. You also have access to the simulation application and the robot application via terminal so that you can perform some basic debugging and triaging functionalities. Here you can leverage common ROS related commands such as ROS node list, ROS topic, echo, or any other, so that you can interact with the simulation in real time and debug or triage. Now that you've seen how to run a simulation application in AWS RoboMaker using the one-click sample application, let's now go and check out how you can generate a 3D world using WorldForge functionality. To do that, on the left tab, select the World Template section. We will first create a template that gives the general idea and parameters that describe the world that we want to generate. AWS RoboMaker by default provides a few sample templates that you can get started with. Here, you can see that we have templates available for a bedroom, a 2-room floor plan, and a 1-bedroom apartment and a small house. For this demo, we are going to use the 1-bedroom apartment and select it. Here, we can see the console that provides us the ability to modify the template so that we can describe the kind of world that we want to generate. We have the ability to set the size of the bedrooms, the aspect ratios, the kind of connections that we want with in between different rooms in your world, the dimensions, and also you have the ability to select the interiors, flooring, walls, furniture within this template. And once you set this template, AWS RoboMaker WorldForge takes care of selecting a variation of the floor plan and the assets that are available within this template and generates a world for you. Let's save and exit this template. This is the template that we've just created. We're going to go ahead and select it and generate worlds from this template. We have the ability to select the variations in the floor plans and the variations of materials, textures, furnitures within the floor plans when we are selecting the worlds. For this demonstration, I'm going to select 2 floor plans and 2 variations within each of those floor plans, which gives us a combined number of 4 worlds that are generated from this. RoboMaker has a limit of 50 worlds that you can generate at each generation job. The generation may take a few minutes to complete, and you can keep track of the progress from the console over here. In the background, AWS RoboMaker is taking care of running these generation jobs concurrently so that you are able to get your worlds as quickly as possible. Jumping a bit ahead in time, we can see that the generation job has been completed and actually have a preview of all the worlds that are available for us to see. You can see here that AWS RoboMaker WorldForge has generated 2 variations of the floor plans. You can see the difference between this image, which has a certain floor plan, and this one that has a separate floor plan, and 2 worlds and variation of furniture and assets and materials within these worlds. Now, WorldForge worlds are supported first class with AWS RoboMaker simulation jobs. What does that mean? It means that to actually import this simulation world into your application, all you have to do is click a couple of buttons and say the world that you'd like to use. To show that, we will be reusing the sample application that we just created with the one-click sample app. In the repository, you will notice that we have a launch file specifically available for AWS WorldForge worlds. In Cloudwatch Simulations launch section, you will notice WorldForge Turtlebot Navigation.launch. Here, we use the launch file that is available from our AWS RoboMaker WorldForge world to kick things off. So, all we need to do now is go back to our simulation jobs. We will be using almost the exact configuration of this simulation job. So let's clone it, and we will be changing the launch file used to launch the application. The sample application supports WorldForge worlds directly, so all we have to do is change the launch file from the bookstore Turtlebot navigation, which launches the Turtlebot robot in a bookstore world, to a WorldForge Turtlebot navigation.launch file, that is available in the repository. And then we can go to the tab that says Import World from WorldForge, browse a specific world. We've generated 4 worlds, so let's pick this one that looks like this. Choose world and then create. This way, you are able to connect your application to a WorldForge world that has been generated without having to change any code. With Batch API functionality that is available in RoboMaker, this provides a powerful option to launch your simulation application in different environments just by changing the configuration to your Batch API without having to change any code. This gives the ability to test your robots in different environments so that you can have more robust testing and have higher confidence when deploying your robot application onto a physical robot. Now we have the simulation application running. We can click the GZ Client application tool that is available to visualize the 3D world in which the robot is running. We can see that this is the world that we just generated using AWS RoboMaker WorldForge with the assets, furnitures, and models all available in this world. This way, by generating a large number of worlds, you will be able to get variation in scenarios and environment so that you can ensure that the robot goes through robust testing and have higher confidence in its performance before being deployed onto a physical robot. Thank you for watching the demo.